Today's lesson is on evaluating exponential functions. So we're going to build the function, and then we're going to actually evaluate it at a certain number. So suppose that you have $200. You invest this money into an account, earning 5% interest each year. How much money do you have in 7 years? Okay, well, just to recap, our function is this for exponential. This is my starting value, this is my growth or decay, and this is my time. So what was my starting value? $200. I am earning 5%. So I take 100% and I add 5% to it. I get 105%. But to take the percent sign off, I have to scoop my decimal twice. So 1.05. To the, that's my time, and I'm going for 7 years. When you know everything on the right-hand side of the equation, I just take my calculator and I type in 200 times 1.05 to the 7th. And so this is money, so we're going to go 2 decimal places. So I've made $281.42. $281.42. Okay, number 2. The function p of t equals 100 times 1.05 to the x. Models population p in thousands. So if this is my starting population, that's not 100 people, that's 100,000 people of a city from 1992 to 2004, where t equals 0 represents the year 1992. If the growth rate remains the same, about how many people does the model predict will live in the city in 2010? Well, they gave me my function. I know that I had 100,000 people to start with. Looks like I'm growing at 5%. The question is, how long are we going? Well, I'm going until 2010. So do I put a 2010 up there in my power? And the answer is no. T equals 0 represents 92. So what I need to do is see is how much time has passed from 1992 to 2010. Answer's 18. If you don't know that, then you're just going to take your calculator and you're going to subtract 2010 minus 1992. So it's to the 18th power. So then I take my handy-dandy calculator and I do 100 times 1.05, again growing at 5%, to the 18th. And I have 240.662. So 240.662. So does this mean 240 people? No, remember this is in thousands. So this is 240,662 people. So then look at your answers. And 241,000 is going to be the closest. Carl and Jesse paid $215,000 for their house overlooking the beach. If the house appreciates at a rate of 3% each year, what's the closest estimate of the value of the house after 5 years? Okay, so y equals 215,000, that's my starting value. We are appreciating 3%, so 1.03. And I'm going for 5 years. So I just type it in. 215,000 times 1.03 to the 5. $249,243.93. So looks like A. If you want to look at those again, $249,243.93, so they rounded up to the nearest dollar. 3 years ago, Alex invested $5,000 into an account that earns 5% interest compounded annually. Andy made no additional deposits or withdrawals. How much money is in the account now? He started with $5,000. It's earning 5%. Well, I want to know now. Well, how many years is that? Well, 3 years ago is when he put it in there, so it's been going for 3 years. And then I just take my calculator, 5,000, $5,788.13. Looks like D. Since 1985, the daily cost of patient care in community hospitals in the U.S. has increased about 8.1% per year. In 1985, such hospital costs were average of $460 per day. Find the approximate cost in 2000. What I've noticed is a lot of students will say y equals and they'll plug in a 1985 right here. That's not my starting value. That's a year. You've got to make sure that you're really taking time to read the question. What is it that's increasing? It's hospital cost. They started at $460 a day. We are increasing 8.1%. So 100 plus 8.1 is 108.1. Scoot your decimal twice. 1.081. Now, how long are we talking? 1985, they were 460, and I'm going to 2000. So how many years is that? If you're not sure, you just subtract on your calculator, but it's going to be 15 years. So 460 to the 1,479 and, okay, now would this be 59 cents? No, it would actually go up to 60 cents because the 6 that's behind the 9 tells the 9 to round up. So the 59 is going to round to 60. So $1,479.60. So kicker for that one is just make sure you take your time and read carefully. Don't just find numbers and plug them into formulas. Make sure you're finding the right information. In 1998, there were approximately 430,000 people employed in the U.S. as computer support specialists. According to the U.S. Bureau of Labor Statistics, that number was expected to grow 7% annually. How many computer specialists will there be in 2007? Okay, how many do we have to start with? We have 430,000. We are growing 7%. And I want to go to 2007, and I'm starting in 1998. So let's see, 7, 8, 9 years. And if you can't do that in your head, then you just subtract 2007 minus 1998 to get your time. Sorry. So then I take 430,000 times 1.07 to the 9. So 790,537. Now this is a decimal, but we're talking about people. So what I really want to do is look at that first 4 that's after the decimal, and since it's only a 4, I'm not going to round up. So it's just going to be 790,537 because it's people. Okay, changing gears. So far, I have asked you what the value would be after a certain amount of time. But now I'm going to tell you what I want the value to be, and I want you to tell me how long it's going to take to get there. So we have a new automobile, and it's purchased for $20,000. What does that mean? Well, that means it's depreciating 20%. how long, so I want X, I don't know what it is, will it take the car to be worth half its purchase price? So half its purchase price would be $10,000. Well, this is really cool, something your calculator can do. So I'm going to go to my y equals, and I'm going to type in my function, 20,000 times 0.8 to the x. And then where can we go so that we see a list of all of the values? And that's your table. So I'm going to go to my table, but I'm going to go back up to 0 where it starts. Hold on. There we go. So starting at 0, I can see the value of the car is $20,000. So what happens after year 1? Well, it's gone down $4,000. And then year 2, it's gone down a little over $3,000. And then year 3, it's gone down a little over $2,000. So it's decreasing at a decreasing rate. That's what makes it exponential. So it loses more of its value up front, and then after a while it loses less and less. What I want to know is, when is the car going to be worth $10,000? You got to really, really watch your zeros here. So $10,000 looks like I'm sitting at it at about 3, because if I go 4 years, it's going to be 8,000. So multiple choice, my choices are 2, 3, 4, and 5. Well, 2, it's almost 13,000. That's too much. 3, it's just a little bit over 10,000, so I'm going to go with that one. Now, if this was not multiple choice, technically at 3, we haven't hit 10,000 yet. So you can do something on your calculator to sort of fine tune and figure out exactly where it hits 10,000, or maybe not exactly, but a little bit more close. So if you go to your table set, go to your table set, I know the action happens at 3. And I'm going to change my delta table, which is what it goes up by. Instead of 1, I'm going to go 0.1. Then I'm going to go back to my table. So I can see at 3, yeah, I knew it was at 10,240, but look at 3.1. It's $10,014. Now at 3.2, it's already down to 9,700. So 3.1 is much more close to 10,000 than just a plain old 3. So if this was not multiple choice, I would have fine-tuned it, and I would have put 3.1 as my answer. And again, that's under table. That's under table set. Under table set on your calculator. So now that I've altered it, I'm going to go back and fix it. So I'm going to go back to table set, change my start to 0, and my delta table, my change back to 1, just to make it normal for the next problem. Okay, so let's try this again. You invest $1,000 into an account that earns 3.5% interest. How long will it take for your money to be worth triple the original amount? So y equals $1,000. I'm earning 3.5, so 100 plus 3.5 is 103.5. Scoot your decimal twice. 1.035. And I don't know how long we're going, but I want it to be worth triple. So if I start with 1,000, triple would be $3,000. So I'm going until I hit $3,000. So I go y equals, and I clear that sucker out. 1,000, 1.035 to the x, because I don't know how long we're going. And then I'm going to go to my table. So start at 0. There's my $1,000, and it's increasing in value, I can see. And I want to go until I hit $3,000. Well, there's 2,000. There's 3,000. 32 is $3,006. So it takes 32 years. The values of expensive products like automobiles depreciate from year to year. One common method for calculating the depreciation of an automobile assumes that a car loses 20% of its value every year. Suppose you purchase a new car for $20,000. Estimate the time when the car's value is only $1,000. Poor thing. All right, so here we go. I'm going to go V for value. So value, and we start with a $20,000 car. I'm depreciating 20%, so that's going to be 0.8, because I do 100 minus 20. I don't know how long we're going, but I want to go until we hit 1,000. So I grab my calculator, I go to my y equals, I clear that out. 20,000, 0.8 to the x, go to my table, and I want to go, all right, I need to go back to my table set, and I want to start back at 0. There we are. So 20,000, and I want to go until I hit 1,000. Well, it looks like it happens somewhere in between 3 and 4. So I'm going to go table set. I know it's going to happen somewhere around 3. I'm going to change my delta table to a 0.1. Go back to my table, and let's find when it's 1,000. 3.6, it's, hold on one second. Oh, I see what I did. All right, hold on. I have typed something in wrong. Let's try it again. There we go. Okay. Sorry, typed it in wrong. Now let's go to table. Okay, so here's my $20,000, and I want to go until I hit 1,000. Okay, well, it looks like it happens just after 13. So I'm going to fine tune it. I'm going to go to my table set, and we just said it's going to happen somewhere around 13, and I'm going to change my delta table to a 0.1. So now let's see how close to 1,000 I can get. That's within $5. That's pretty good. So I'm going 13.4. 13.4 years. Okay, so basically there are two types of problems. One where you know how much it's starting with, what it's appreciating or depreciating with, and how much time is going. And those are super easy. You just plug them into your calculator. Then the other ones are when I have this and I have this, but I don't have this, but I know how much I want it to be worth. And that's when you go to your calculator, plug it into your y equals, and then go look at your table. And just go until you find the value you're looking for.